Yo, what's up YouTube? Today is day 29 of the daily LeetCode challenge of March. We have 3 more questions left, including this one, so let's do it. Today's question is question 2962. Count subarrays where max element appears at least k times. You are given an integer array nums and a positive integer k. Return the number of subarrays where the maximum elements of nums appear at least k times in that subarray. A subarray is a contiguous sequence of elements within an array. Okay, so this is another sliding window question, or a subarray question. And we know that in subarray questions there are a possibility of n squared subarrays. So we want to use a sliding window technique to bring the runtime down to just O of n. So our first step in solving this question is finding the max element, and we could just use max of nums. So we found the max element. Now our idea is to have our window situated between the maximum element appearing k times. So we want our window to be like this, 3 2 3. We don't want it to be 1 3 2 3 because we don't need the 1 here. We just want it exactly small enough, or we want it as small as possible so it fits the criteria. So we want the sliding window to be like this, and when our pointer iterates and it goes up to here, and now we have 3 k elements, we want to cut off 3 and 2, so our window is just 3 and 3, if that makes sense. So we are going to use a left and right pointer. Our right pointer is going to iterate the entire list. Left pointer, our left pointer needs to strictly know when k is oversatisfied. So our left pointer needs to keep count of max element exactly as k. So if example 1, if k is 2 and we get a window like this, our left pointer will know that k has become 3, so it will have to keep iterating forward until it loses those extra elements. And then every time we find a valid sliding window, we will add the left pointer to our answer, including itself. So if we have a sliding window, valid sliding window like this, right, 3 2 3, the left pointer is at 1, our answer will be +1 +1. So +1 is the left pointer, and then +1 where it adds itself. So we add +1. We add the left pointer because it basically tells us how many elements is before the left pointer. So that basically accounts for all the subarrays before our left pointer. So let me give this example, right? We have 3 3. Our left pointer is at 3. Left pointer is at 3. So that means there are 3 elements before our left pointer that are valid subarrays, because 2 3 3 is a valid subarray, 3 2 3 3 is a valid subarray, 1 3 2 3 3 is a valid subarray. So if our left pointer is at this valid window, we add the left pointer, which is 3, which accounts for all the subarrays before it, and then we add itself, so +1. So it would be +3 +1, if that makes sense. And then return our answer. So the runtime of this is just O of n. We do 1 pass with the right pointer, and our space is O of 1. We don't store any structures. We only use variables. So let's do it. So our max element is the max of nums. And then we need a left and right pointer. Oh, actually, let's just do left pointer 0 for r in range length nums. Yes, length nums, and then we do the range. Okay, we need our answer variable, and we also need a counter variable to count how many max elements we found. So for r in range, if nums r is equal to the max element, then we will increment our counter, and then our left pointer needs to keep count of max element exactly as k. So if counter is greater than the k variable, then we need to, so while the counter is greater than k, we need to iterate L. So if nums L equal max element, then counter minus equal 1. And then we move L forward until we find the correct window. So now that we found the correct window, oh, actually, we need to throw in L has to be less than R. We don't want L to go past R. Okay, and then we need to find a valid sliding window. We'll add the left pointer to our answer, including itself. So when we find a valid sliding window, our answer will just plus the left pointer and then plus 1. Okay, now let me make sure I'm not missing anything. Okay, I'm gonna just run the code and see if it works. I see. So what we're missing here is left pointer needs to keep count of max element exactly as k, as well as left pointer also needs to stay on a max element. For example, in those strict valid window examples that I gave you, you can notice that the left element is always on a max element. For example, 3, 2, 3, left is always on a 3. 3 and 3, left is always on a 3. So we want to iterate L as well. We want to iterate L when counter is oversatisfied, which is this block of code here. So we took care of that scenario, but there is a edge case where we could have a window where k is not oversatisfied. However, the left pointer is not on a max element. So we just have to make sure that nums of L is equal a max element. So while is not equal a max element and L is not before R, then we just do L plus 1. There we go. 4, 2, 1. Let me throw in this test case and then. Okay, ready to submit. And there we have it, folks. Thank you for watching. This is day 29 of the Daily LeetCode Challenge. We will see you in the next one. Goodbye.